Voyager 1 is dying. Not from a crash, not from a failure. It's running out of power, nothing more. And when the last watt fades, sometime in the 2030s, the farthest voice we've ever sent into the dark goes quiet. Then it keeps flying, deaf and mute, for 1 billion years. Here's the thing most people get wrong. They assume it died long ago. A relic, a fun fact from a textbook, something that stopped talking back when they were kids. It didn't. Right now, tonight, while you read this, a machine the size of a small car is still whispering to us from the space between the stars. From a place so far away that its signal, moving at the speed of light, takes almost a full day to reach your planet. And on April 17th, 2026, a team at NASA's Jet Propulsion Laboratory did something quiet and final. They sent a command across 15 billion miles, a command that took nearly a day to arrive, and switched off one more of its instruments. Not because it broke, because there wasn't enough power left to keep it warm. So the question under this whole story is small and heavier than it sounds. We're about to lose Voyager 1 forever. What exactly do we lose when it goes silent? Start with the power, because the power is the clock counting down. The Voyager spacecraft doesn't run on sunlight. Out there, the sun is one more bright star. It runs on the heat of decaying plutonium, turned straight into electricity. When it launched, that source produced about 470 watts, enough to run 10 scientific instruments and a radio loud enough to be heard across the solar system. There was no way to refuel it, and no way to fix it. Whatever it left with was all it would ever have. That was 1977. Every year since, the spacecraft has lost close to 4 watts. Picture a house where one bulb burns out annually, and none of them can ever be replaced. First a lamp goes, then a room, then a whole floor falls dark. By 2026, Voyager 1 has enough power for 2 instruments. 7 of its 10 are already switched off, and the radio that carries its voice grows fainter every year. So the engineers at JPL do a grim kind of arithmetic. Every watt has to be spent, and once spent, it's gone for good. Their newest power-saving scheme even has a nickname, the Big Bang. A last-ditch plan to buy the mission a few more years. Suzanne Dodd, who runs it, said the decisions now demand far more caution than they used to. The machine isn't broken. Or, that's not quite the right word. It's starving, and a small group of people are quietly choosing what it gets to say last. To understand what's ending, go back to the beginning. In the mid-1960s, a graduate student named Gary Flandreau noticed that the outer planets were about to line up in a pattern that returns once every 176 years. A probe launched at the right moment could use each planet's gravity as a slingshot to reach the next, a free ride to the edge of the solar system, one that wouldn't come again for 2 centuries. NASA built 2 spacecraft to catch that window. Voyager 1 left Earth on September 5th, 1977. It was designed to last 5 years. Reach Jupiter, reach Saturn, send home the postcards and go quiet. That was the entire plan. 5 years. It has now been running for 49, and it is still returning data no one else can. Say that again. A machine with less computing power than the key fob to your car has operated in deep space, without a single repair visit, for close to half a century. The engineers who launched it are now in their 70s and 80s. It was never meant to still be talking. And what it found out there, past every planet, past the edge of the sun's reach, is the reason we still can't look away. Before the Voyager spacecraft left us, it handed us the solar system. In March 1979, it reached Jupiter, mapped the storm we call the Great Red Spot, and then caught something no one had predicted, a small moon called Io, throwing volcanic plumes hundreds of miles into space. The first active volcanoes ever found beyond Earth. It also spotted a faint ring around Jupiter that had gone unseen from the ground. and lightning flickering deep in the giant's clouds. Until that moment, we believed our world was the only one still alive with fire. Then Saturn, in 1980. Its rings, smooth and simple from Earth, shattered into thousands of separate strands, braided, kinked, twisted in ways the physics of the day couldn't explain. New moons appeared in the images, and a haze-wrapped world called Titan turned out to hold a thick nitrogen atmosphere, not unlike the young Earth's. NASA wanted that close look at Titan so badly that they aimed Voyager 1 to get it, a choice that flung the spacecraft up and out of the plane of the planets and gave up any chance of it ever visiting Pluto. And then it did more than anyone had asked of it. It kept going. Its cameras had nothing left to photograph. On paper, the mission was finished, but the radio still worked. The plutonium still glowed. And so Voyager 1 aimed itself at the emptiness beyond the planets and flew on, toward a boundary no machine from Earth had ever crossed. Our sun does something you can't see from the ground. It blows a steady wind of charged particles in all directions, and that wind inflates an enormous bubble around the entire solar system. Everything you've ever known, every planet, every person, all of recorded history, has lived inside it. The true border of the sun's kingdom isn't Pluto, and it isn't the last planet. It's the edge of this bubble, more than 11 billion miles out. For 35 years, Voyager 1 flew toward that edge, and the edge turned out to have layers. In 2004, it hit the termination shock, the place where the sun's wind slams into the thin gas of the galaxy and abruptly slows. Then came years of churning no man's land the scientists named the heliosheath. Only in August 2012 did it finally break through the outermost skin, the heliopause, and its instruments caught the exact moment it crossed. The sun's wind fell away. Particles born around other stars flooded in. For the first time, an object built by human hands was outside the bubble, in interstellar space, the space between the stars. Sit with what that means. Everything our species has ever touched, launched or lost, has stayed inside the sun's shelter. Voyager 1 stepped out of the house into the night, for the first time in the history of life on Earth. It became the first piece of us to exist in the space between suns. And the moment it crossed that line, the numbers it sent home stopped making sense. Scientists expected the wind out there to slow gently and drift onward. Instead, Voyager found it nearly stop, and at times, flow backward, inward, toward the sun. No model had called for that. Then the magnetic field, near the sun, it flips direction every 13 days as the star spins. Out past the edge, a single flip took more than 100 days to sweep across the spacecraft, and the sun's field and the galaxies seemed to connect across the boundary, threaded together in a way no map had ever shown. And you'll hear other channels call that boundary a wall of fire. 30,000 degrees. Some say 50. Here's the honest version. The number is close to real, and the way they use it is a lie. Out there, the gas is so thin that its temperature carries almost no heat. A spacecraft can drift through 50,000 degree plasma and barely feel it, because there's next to nothing there to burn. The temperature is genuine. The fire is invented. The real surprise was quieter and stranger. The cosmic rays, high-energy particles from deep space, were supposed to peak at the boundary and fade. They didn't. The deeper Voyager pushed, the stronger they grew, which means their source lies somewhere out there we still haven't mapped. 3 predictions about the edge of our own solar system. 3 of them wrong. And the only instrument close enough to tell us why is running low on power. Here's the discovery I can't stop thinking about. In 2017, Voyager 1's plasma wave instrument picked up a sound. Not a message from anyone, but a faint, steady hum in the gas between the stars. A team led by Stella Ocker at Cornell published it in the journal Nature Astronomy in 2021. The space between stars, which we had always pictured as silent and empty, is quietly ringing, and Voyager is close enough to hear it. Now, this is the exact spot where weaker channels lie to you, so let me be straight about it. There are two solid explanations for that hum, and both sit comfortably inside known physics. It is not a signal from anyone. It is not unexplained. It's a small, real discovery about how turbulent the space between the stars is. A measurement no telescope on Earth can make, because you have to be out there, inside the emptiness, to take it. And it's arriving on a battery that loses 4 watts a year. Think about that pairing. The most delicate reading ever taken of interstellar space, carried home by a dying machine, across a gap so wide it beggars the imagination. The closer we lean in to listen, the louder the question underneath grows. What happens to all of this the day the power finally runs out? Voyager 1 has a twin. Voyager 2 left Earth 2 weeks earlier, took the slow road past Uranus and Neptune, and crossed into interstellar space in 2018. 6 years behind its sibling, heading in a completely different direction. 2 machines, launched together, now drifting out of the solar system on opposite sides of the Sun. Before Voyager 2 left the planets behind, it gave us our only close look at Uranus and Neptune, a dark storm the size of Earth, and ice volcanoes erupting on Neptune's frozen moon Triton. Decades later, no spacecraft has ever gone back. Here's the part that unsettles the scientists. Both probes crossed the edge of the bubble at almost the same distance from the Sun, about 121 astronomical units for one, 119 for the other, despite leaving in different directions, years apart, during opposite phases of the Sun's cycle. Researchers at Johns Hopkins studied that symmetry and admitted they can't yet explain it. Our Sun's bubble may be a shape we don't understand, and the twins keep settling old arguments. When Voyager 2 swept past Uranus in 1986, its radiation belts read far stronger than they should have been, a puzzle that stood for nearly 40 years. In 2024, scientists finally cracked it. The spacecraft had arrived days after a solar storm squeezed the planet's magnetic field, catching Uranus in a freak, fleeting moment. One probe, one flyby. Still solving mysteries with data taken before most people alive today were born. Once these two go quiet, that kind of measurement can't be retaken. Not by us, not for a long time. Voyager 1 should have died several times already. In late 2023, its onboard computer began sending back gibberish. 5 months of meaningless ones and zeros, as if the spacecraft had suffered a stroke. A single chip had failed. The engineers had to find the corrupted section, rewrite the code, and route it around the dead piece, performing surgery on a computer 15 billion miles away with a signal that took 22 hours to travel each way. One of them called it remote neurosurgery. It worked. Then the thrusters. The tiny jets that keep the spacecraft pointed at Earth had slowly clogged with residue until the openings were narrower than half a human hair. So in 2024 and 2025, the team revived a set of backup thrusters that had been written off as dead for more than 20 years, gently warming them from across the solar system, racing a deadline before the one antenna on Earth big enough to command Voyager was taken offline for repairs. If the spacecraft ever drifts more than 2 degrees off Earth, its antenna loses us, and the conversation ends. Not in the 2030s, but that day. They keep saving it. A dead computer, a dead thruster. Repaired from 15 billion miles away again and again, and each time they win. But there's one wall no rescue can climb. You can reroute a chip. You can revive a thruster. You cannot refill plutonium. The single thing killing Voyager 1 is the one thing no engineer on Earth can fix, and it is winning 4 watts at a time. So the team faces the hardest job in spaceflight. They switch their own spacecraft off, one instrument at a time, knowing each choice is permanent. There is no turning it back on. As the power drops, someone has to decide which sense the probe loses next. Its feel for magnetic fields, its ear for the plasma, its count of the particles streaming past. In April 2026, they shut down the instrument that measured charged particles. 7 of 10 gone. 2 left. Each of those 2 carries a stream of data collected nowhere else in the universe, a record that ends for good the instant it stops. And the choice of which to sacrifice next falls to the same small team. Every time, sit with the weight of that. The people who gave their careers to keeping this machine alive are the same people who now decide how it dies. Not whether, how. Which whisper is worth the last of the power? They are holding a vigil for a patient 15 billion miles away. And every switch they flip forever. Now the number that makes all of this real. On November 18th, 2026, Voyager 1 reaches a distance no human object has ever touched. 1 full light day from Earth. A radio signal, moving at the speed of light, the fastest thing that exists, now needs an entire day to reach it. 16 billion miles of emptiness between us and the machine. Susie Dodd described what that feels like to operate. Send a command. Good morning, Voyager 1, on a Monday at 8 a.m., and the spacecraft's reply won't land back on Earth until Wednesday morning. 2 days to say hello and hear it answer. It is the longest, slowest conversation our species has ever held, stretched across a gap so vast that light itself needs a day to cross it. The spacecraft sits about 15.8 billion miles out, and the gap widens by another million miles a day. Voyager transmits with about 23 watts, the power of a dim light bulb. By the time that signal reaches Earth, it has faded to less than a billionth of a watt. To catch it, the Deep Space Network aims dishes the size of stadiums at one patch of sky and pulls that whisper out of the noise. And it gets a little harder every year, and the Voyager spacecraft is racing that widening distance against its own fading power. Every year, the signal grows fainter, and the gap grows longer. It is the most extraordinary phone call humanity has ever made. And we are about to lose the voice on the other end of the line. Not to the distance, to silence. Bolted to the side of Voyager 1 is a gold-plated record. In 1977, a small committee led by Carl Sagan tried to answer an impossible question. If this is the one thing of ours that leaves forever, what should it say? They chose 115 images, spoken greetings in 55 languages, and 90 minutes of music. Bach and Chuck Berry's Johnny B. Good, and a piece by a blind street preacher named Blind Willie Johnson, a wordless, aching blues called Dark Was the Night, often called the loneliest song ever recorded. It is now the loneliest sound in the universe, flying farther from home than anything a human has ever made. They recorded a mother's heartbeat, thunder, the song of a whale, human laughter. Andrea Ann, who helped make the record and later married Sagan, had her own brainwaves recorded while she thought about what it means to fall in love, so that some mind in some far future might read the electricity of a human heart. On the cover, they etched a map of pulsars, a set of cosmic landmarks that points the way back to Earth. And in 1990, before its cameras were shut down to save power, Voyager 1 turned and took one last photograph. Our whole world reduced to a single pale blue dot, smaller than a pixel, 6 billion kilometers away. Here is the cruel, beautiful split at the center of this story. That record will keep flying long after the radio dies. The message outlives us, but a message only speaks. What we're about to lose is the part of Voyager that still answers back. When the Voyager spacecraft finally goes quiet, we don't lose a mascot. We lose the only working sensor our species has ever placed in interstellar space. Every computer model of the sun's bubble, every prediction about the border that shields our whole solar system from the galaxy, is anchored to the real measurements these two probes took from inside it. Pull that anchor, and the models drift with nothing left to check them against. And here's what almost no one says out loud. There is no replacement coming. A true successor, a mission designed to fly into interstellar space, exists only as a concept on paper, unfunded. Even if it launched tomorrow, it would need more than 25 years to reach where Voyager already sits. NASA does have a newer probe, IMAP, studying that boundary. But it watches the edge of the bubble from near Earth, mapping it from a distance. It cannot stand where Voyager stands. There is no Voyager 3. Not now. Perhaps not in our lifetimes. So the silence isn't one old spacecraft going dark. It's the moment humanity loses its only eyes at the edge of the sun's kingdom, and doesn't get them back for a generation, maybe longer. We're about to go blind at the exact place we finally learned to see. There's a quieter loss folded inside the loud one. The people. Voyager 1 was built in a computer language most programmers today have never touched. Assembly code from the 1970s, written for hardware that exists nowhere on Earth anymore. The engineers who still speak it are the last generation who can. Some have worked the mission for 40 years. When they retire, the knowledge of how to talk to this spacecraft, how to coax it back from the edge of failure, retires with them, and it all comes down to a single dish. In Canberra, Australia, a 70-meter antenna called DSS-43 is the only instrument on the planet powerful enough to send commands to Voyager 1. One dish in one hemisphere. When it was taken down for upgrades, we couldn't speak to the spacecraft at all for months. We could only listen and hope it was still holding its course. So the thread between us and Voyager 1 is thinner than most people picture. A dying battery, a single antenna, a handful of aging engineers who still remember how it thinks. Lose any one of the three, and the silence that follows isn't only the spacecraft's, it's ours. So, what do we lose the moment Voyager 1 goes silent forever? Not our understanding of physics. That's the story the loud channels sell. The truth is quieter, and it lands harder. We lose the last thing built by human hands that still answers back from the dark. For 49 years, we have been able to send a question into interstellar space and receive an answer. A real one, from out there. Sometime in the 2030s, that ends. Not with an explosion, not with a failure, with a battery too weak to whisper. Somewhere at JPL, an engineer will send one final command and wait through a 2-day silence for a reply that never comes. That is the moment the conversation becomes a monologue. The record flying on, still speaking, with no one left on Earth able to hear it answer. And the machine won't even notice. Moving at 17 kilometers a second, the fastest object ever to leave the solar system, it will keep flying exactly as it does now, carrying its golden record and its photograph of a pale blue dot into a silence with no floor. Voyager 1 is dying. Not the way a machine breaks, the way a voice goes quiet while the messenger keeps walking. Even at that speed, it won't leave the sun's gravity for another 30,000 years. In 40,000, it will drift within a couple of light years of another star. Long after we are gone, After every name we have ever spoken is forgotten, a small piece of Earth will still be out there in the dark, holding a mother's heartbeat, carrying it toward the stars. We will no longer be able to hear it answer, but it will still be out there, still flying, still ours. That's as far as this one goes, but the edge always moves. This is Aphelo. Subscribe, drop a like if it earned it, and your next one's on screen now. I'll meet you a little further out.